This video is a quick video giving some hints on how to solve examples number 10 and 11. The first example, which is problem 7 in your textbook, asks you to calculate the normal force on a 15-kilogram block in the following circumstances. In each case, what I'm really looking for is the magnitude of the normal force, not just the normal force itself. In other words, I don't care so much about direction. For each of these 4 portions to this problem, your very first task will be to draw a free body diagram. After you draw a free body diagram, you will write a net force equation or net force equations, depending on the situation. After you write those equations, you will then algebraically solve for the normal force and then plug some numbers in. A couple of hints on each part. In part A, it says the block is resting on a level surface. This means that the net force is 0 because the acceleration is 0. In part B, it says that the block is resting on a surface that is tilted. In this portion, it is to your advantage to tilt your axis, similar to how we did in the previous example problem. In part C, the block is resting on a floor of an elevator, and the elevator is accelerating. That means the block must also be accelerating because it is moving with the elevator. And in part D, we have a force that is at an angle that is exerted on our block. For part D, you will need 2 net force equations. And to remember that a block is going to stay on the level surface even though the applied force is at an angle. Pause the video now and try each problem. When you unpause, the answers to each problem will be there. Here are your answers to the 4 portions of this problem. 147 newtons for A, 127 for B, 192 for C, and 84.5 for D. If you have any questions about how to obtain these answers, your first task would be to either go to the internet or a friend who was in class today. After that, I'm happy to answer questions during a free mod. The second problem that we looked at today is this problem where we have 2 masses connected by a rope that are being pulled. In this case, part A is asking us to use the system approach to find the acceleration of the 2 blocks. The system approach means that you treat both objects and the rope that connects them as one object. So it is as if we have one total mass that is being accelerated by an applied force. In part B, you'll then need to treat each mass as its own entity. In part B, since we have 2 masses, you should be drawing 2 free body diagrams, one for M1 and one for M2. You will then write net force equations for each mass. You could write 2 net force equations for M1, one equation for the x direction and one equation for the y direction for M1. You could also write 2 equations for M2, one for the x direction and one for the y direction. You will then need to calculate the tension in the string by looking at either M1 or M2. Again, pause the video and try this problem. When you unpause, you will see the answers. The acceleration of the system is 3 meters per second squared, and that is to the right. And the tension in the rope is 48 newtons. You could consider that tension to be either to the right or to the left, depending on whether you're looking at block 1 or block 2. Again, if you have any questions, the internet or your friends who were in class are a great resource, but I am also happy to answer any questions that you have during a free mod.